Welcome. This seminar is about digestion. It's basically, I call it a basic digestion seminar and about heartburn. Those of you who are listening today might be listening because you are members of Healthy Out West, and we have many members here in the audience. Those of you who are not members, welcome. I will give you a little bit of background of where I'm at. My name is Sherie Julian. I am a nutrition health coach. I'm nationally certified as a nutrition health coach. Those of you also in this room, that is my actual title. In this state, that's what I'm allowed to be called. I also like to be called a health educator. So I would rather actually you call me a health educator, and the reason why is because nutrition health coach is this big long name, and a lot of people end up shortening it to nutritionist. If you call me a nutritionist, you're implying that I'm licensed or I'm like a licensed dietitian. And a licensed dietitian is allowed to work in a hospital, and they do things very differently than what I do, okay? So if you're sharing with friends and family, say, you know, I have this great person I'm working with, she's a health educator, and I'm totally fine with that title, all right? All right, so we're gonna get right into it. I'm gonna talk about digestion, and basically what we're gonna do is we're gonna go basically a track from the mouth all the way to the bottom side, okay? And I'm going to explain what happens all the way along. I'm going to be as simple as I possibly can because we want everybody from every age group to be able to catch this and get this figured out. So this isn't going to be something that you would get from a doctor who comes at this from a different angle. We're going to be as simple as we can with this. All right, so let's start out with anyone in this room who can answer a question for me. And the question is, what starts digestion? Any ideas? Close. Yeah, you're very close.
What did she say?
What starts to, she said spit. Saliva. Yep. You're real close. The only thing I would say is you have to get the brain involved. So a lot of people say eyesight because when you see the food, all of a sudden it's like, oh, I want to eat that food, right? And so then the salivary glands start. So you're right in when you say saliva, you're real close there. Yeah, also if you were reading a book and the book was talking about a meal, and you were reading along and your salivary glands would already start, right? And so then you'd be swallowing. And as soon as you start swallowing, it starts signaling to the body that I'm ready for digestion, right? So that starts it. How many times should you chew the food? Anybody got that question down? 20. 20, you're close.
100?
No. It's actually right around 30, 35, right around there, okay? So this is my challenge for all you guys. Yeah, each bite, like 30 times, yeah. So this is my challenge for all you. Next time you go into a meal, chew it until it becomes liquid in your mouth, okay? You actually should, I know I get all kinds of faces here. You actually, when you chew it and it becomes liquid in your mouth, it actually is like, you can't even tell you're swallowing because it literally slides down the back of the throat. I know.
Disgusting.
Everybody's like, this is gonna gross me out, right? Exactly. So that's my challenge. You guys by YouTube, that's my challenge. I want to challenge you to go ahead and chew your food really, really good and see what that's like. Spend a meal working on chewing your food. Okay? When you chew your food, there's actually an enzyme in your mouth, and that enzyme starts to break down that food. So digestion actually starts in the mouth. And it starts breaking all of that down. It goes down the esophagus, gets to the upper chamber of the stomach, okay? One of the great things that happens in the upper chamber of the stomach is the body takes inventory. It wants to know, what did you swallow? The reason that's important is because there are certain foods that get digested in different areas. And the stomach is in charge for digesting protein. So it wants to know, how much protein did you swallow? Most people know that the stomach has something called hydrochloric acid. So this comes to my third question. Can anyone in this room tell me if hydrochloric acid digests the food? Got people shaking their head? No. Some of you guys are pretty smart. No, hydrochloric acid does not digest the food. What hydrochloric acid does is it activates the protease enzyme, and the protease enzyme helps you digest the food. Okay? So protease actually breaks down protein, and protein digestion happens in the stomach, all right? So if it all happens correctly and the protein gets digested really well in the stomach, It's going to go down to the lower chamber of the stomach, so it's all the same place, but it'll move from the top all the way down to the bottom. And when it gets to the bottom, it should be something that we call chyme. And chyme is a liquid. And it moves from the stomach into the duodenum, which is the first part of the small intestine. And in the duodenum, the first thing that happens when it moves from the stomach into the duodenum is it bathes the food. There's actually a little bath that is given, and it's made up of certain minerals and things like that that bathes the food. And I won't get into big detail there. You can go into big detail about all this stuff. But anyway, it bathes the food, and then the body does the same thing all over again. It takes inventory again, and it wants to know, what did you swallow? And this is very important because it wants to know how much digestion actually happened in the stomach, how much more needs to be happening now in the duodenum. The other thing it does is it takes inventory on how much oily foods you ate. So say you had the standard American diet, which I'm going to grab a couple things so that he can see. So this is your standard American diet. Your hamburger, your French fries, and your soda, right? All right, so standard American diet. This is very common for a lot of people to eat. And I just lost half of the French fries. But, okay, so if you have eaten French fries are very greasy, right? So any fried food, it will take inventory. Say you only ate 10 of them. You ate 10 French fries. It will actually take inventory on exactly how much grease, and of course there's probably some grease in the hamburger as well, but exactly how much grease you swallowed. And depending on how much you swallowed, the body takes inventory because it wants to know how much bile is needed to degrease that. All right? So bile is made by the liver. The liver makes the bile. The gallbladder stores it. Okay? So the signal will be sent to the gallbladder. And it says, okay, they ate 10 French fries. Right? And when they ate 10 French fries, it has exactly this much oil, and we need exactly this much bile, and the gallbladder will excrete exactly the amount that you need into the duodenum so that it can be degreased. Okay, so that happens there. The other thing that happens is the pancreas, anything that did not get digested in the stomach, the pancreas's job, its main job is to give you enzymes so that you can break down your food. 86% of the pancreas's job is to make enzymes, okay? This is your main area. And actually, the bulk of the enzymes being made actually happens between the age of when you're born till you're about 15 years old. After that, the body really slows down. Some people say that it even quits making enzymes at that point. And then it's just storing them until, and you just keep using them, it stores them. But you can get enzymes out of the food you're eating, okay? Green leafy vegetables have a lot of enzymes. And especially if they're good quality, these are all plastic, but okay, so here I've got a green leafy vegetable, right? So they will have enzymes in there. And the more green leafy vegetables, now they have to be raw because any food that's cooked, it kills the enzymes. Okay, anything alive has enzymes. In our bodies, we actually have so many enzymatic reactions that happen in our bodies. I don't know if they even have been able to count them all. That's how many enzyme reactions we actually have in our body. But anything that is alive has live enzymes. And right now, we're just going into summer. You're starting to see the leaves pop out on the trees. So everything is just heating up. And every plant needs moisture, and it needs heat to have life. And you'll get enzymatic life. Now, I can ask in this room, if you have a tree, and you go into winter, all the leaves fall off, right? But is that tree dead? No, it's not dead. It's dormant. That means the enzymes are still there, but the enzymes aren't active. Okay? And so anything when it gets really, really cold, it prevents the body's enzymes from being really active. That being said, remember I said there's so many metabolic and enzymatic reactions that happen within the body. One of the ways, and this is just a little hint, side hint off of digestion, One of the things that happens when we get sick is our body builds a temperature, right? Yeah. So the body builds a temperature, and one of the things it does is it actually rapidly increases, and I forget how many multiple times it increases the enzymatic reactions that are happening inside the body with each degree of temperature. But that particular action helps the body get rid of any sickness or virus or whatever you might have. So it's not always a good idea to really drop a temperature. As long as the temperature doesn't get, extremely high, it's actually good for the body to have a little bit of a temperature because it helps the body get rid of that sickness. Okay? So that being said, the pancreas actually makes all of these enzymes, and it also stores a bunch of them. But whenever you are digesting food, and if you would have eaten the standard American diet, which you got the hamburger, the French fries, and the soda, how much leafy green vegetables are in there? Not very much, right? Might be the pickle, right? And of course the pickle is processed too. Might be the lettuce, the tomato maybe, right? So there isn't a whole lot of enzymes in there. So the body's going to have to use a lot of enzymes from the pancreas to digest that, especially if a lot of it did not get digested properly in the stomach, right? So the other thing that we come across then is we'll start, and I'll get into this a little bit more. I'm going to go through the whole process first, and then I'm going to back up and go to what happens when there's problems with this whole scenario, okay? So the food is right now in the duodenum. If everything happens correctly, then it gets to the after it ends from the duodenum, which is actually a part of the small intestine, but as it moves into the small intestine is not a garden hose like. Okay, most people think of it as a tube. And it is a tube, and it's actually about roughly around 20 feet long for each person, but it's not just a tube, it's actually porous. So it would be more like a soaker hose for your garden, okay, instead of a garden hose, all right? So it's not like just a big hose wrapped around in there, it's very porous. And so you've got this round thing that it's going through, but it has these things that we call villi, and they actually are hairs that go almost clear across it. So it's actually, if you thought of it being closed off, it's not closed off because things can pass through there, but there's hairs in there, and those hairs are called villi. And along those villi, you've got a whole bunch of little enzymes that sit on the edge of those hairs. And as the food passes through there, now hopefully the food is broke down into the smallest particles so that those little tiny villi hair can pick up that food and it can blend with those enzymes and it can get into the system. And then it immediately goes into the hair-like structure of the villi, and then it gets into the bloodstream. And then the body carries that. And really, if you think about who we are, who our makeup is as this body, it's been said we are what we eat. But it's actually more true we are what we absorb.